the question telling? Now, what was the question telling? That there are 5 objects A to E. That means A, B, C, D, and E. 5 objects. And it was telling that B, C, D shows electrostatic repulsion. That means they are having same charges. Let me mark here A and B. Sorry, A as okay. Let me go by this way. A and B, attraction. That means opposite charges. C and E, opposite charges because attraction. Also A and E, this way. A and E. These 3 pairs have same charges. And also it is telling that 2 of them are having same charges because they are showing repulsion. That is B and C, also D and E. Now, first of all, we assume that if A is positive, If A is positive, we have discussed AB shows attraction. That's why we will say that if A is positive, B must be negative because they are showing attraction. A is positive, then A and C, A and E also should be negative to show attraction. And if E is negative to show attraction with C should be positive. We are using this expression, because it means attraction, because so we can say that A and B will be opposite, C and E will be opposite. Like this way we have got this conclusion. Now let us check B and C, this condition. These are showing repulsion. That means B and C should be of same nature, either positive or negative. Now B and C, you see here B and C, each B and C, are they same nature? No, they are negative. That means this is not satisfying this relation. So we will say that our assumption is wrong. A is not positive charge. First of all, this is our first assumption. Our second assumption, we will assume that A is negative. Let A is negative. If A is negative, then to show attraction, A is negative, then B should be positive. A is negative, then E should be positive. And if E is positive, then C should be negative to show attraction. By this relation, we have got this conclusion. Now, verify this through these 2 relations. B and C should have same sign. B and C should have, is it having same nature, same sign? No. That means this assumption is also wrong. Now, we'll take last and third assumption, that A is a neutral body. If A is neutral, then A shows attraction with B. Attraction with B means that B can be either positive or negative, maybe anything. C and E, we assume that B is maybe a positive. Let us assume positive. And A is neutral, then E can be either positive or negative. Let us assume E is also positive. If E is positive, then A should be negative to show attraction. E is positive, then A is neutral. Neutral body can show attraction. We have learned in our previous lecture also. So it is verified. Let us check here. C and E should have same nature, attraction, opposite nature. That means we can say that it should be a negative. Now check here. Check B and C. B and C should have same sign. It is having same sign? No. Now our next assumption, let us assume that it is a neutral. It is neutral, and B is having negative charge. Possible. B is having negative charge. Possible. Also, C is having a positive charge. Possible. C is having positive charge, and C and E shows attraction. That means C and E shows attraction. That means it should be a positive charge or negative charge. Maybe we can see that B and C, are they showing having same charge? Yes, possible. So we will say that neutral is possible case for our answer, because in this case it is possible and it satisfies the relation. So
What is the
answer,
difference between two, sir? I mean, we have taken neutral as A as neutral in both the cases, and we have
yes,
assumed to be positive and negative. So
okay.
either of the things, like they're showing attraction, sir. Here also
Oh,
in the
yes,
last.
I'm knowing what you are having confusion. Let me discuss once more. You will get clear. Let me discuss once more. You will get clear. Let me discuss once more. And let me discuss this once more. You will get clear. Let me discuss this once more. Okay, okay. Now, let me discuss it once more. Now, let me assume A to be a neutral body. A is neutral. If A is neutral, now A and B, they show the attraction. Attraction means B can be either positive charge or negative charge. We are assuming A as neutral, then B can be either positive or it can be negative. We have no condition in that, because they can show attraction. A and E also show the attraction. E can be either positive or it can be negative. Got it? I am mixing that two cases of neutral together. And E and C shows attraction. That means if E is positive, if E is positive, then C should be negative, and if E is negative, then C should be positive. This case possible. Now let us check through first condition. B and C, D and E shows repulsion. That means they should have same sign. Now check it here. B and C. B and C, is it possible that B and C have same sign? You can check
Yes,
here,
sir.
and also D and E. Got it? So we can say that A can be a neutral body, because is it possible here? Okay. Now let us go to our next topic, that is properties of charge, which we were discussing earlier. Any problem till now? Any problem till now? I was discussing these properties of charge is quantized in my previous lecture. Any one of the student is having any problem, please ask. Any student, any question? Let me check. Let me check. Good, good. No problem. Okay. Now, and I request you, all of you, please make an interactive session, because if you will be interactive, I will deliver my best of my lecture to you if you will be interactive with me. Okay, now charge is quantized. I have discussed with you all how we define charge is quantized, and I've also discussed one question with you, and I have also discussed how we have got this formula Q is equal to NE. Now, and we came to know that the minimum charge is possible that it will be E, and it was discovered by Millikan's oil drop experiment. We have discussed in our previous lecture. Now, recently it is also found that protons and electrons, it is breakdown, it is made up of what? Quark. They are made up of quark. What is quark? It is said that quarks are also a charged particle having less charge than one proton or one electron, having less charge than one proton or electron. And it is said that quark is having two parts. One is up quark, it is of two type, that is up quark. One is up quark, and another is down quark, down quark. And it was found that up quark has charge of +2/3 of electron, and down quark has charge of -1/3 of electron. It was found experimentally around in 1995. It was found, one of them. Now it was discovered that to make one proton, two quark up quark and one down quark, adds up together to give one proton. We can check this also. 2 up quark, 2 up quark. If we multiply 2 into up quark is 2 by 3 plus 2 by 3. We can multiply here plus 2 by 3 E like this, and plus 1 down quark. 1 into down quark means 1 by 3. If we add them together, we will get 1 E. That means we are getting one electronic charge in positive nature. That means it's a charge of proton. So we say that one proton is made up of 2 up quark and 1 down quark. And also we can check here, one neutron is made up of 2 down quark. Down quark means 1 by 3 down quark plus 1 up quark. Up quark means 2 by 3 of electron, like this. E. If we will add together, we will get 0, that is neutral, and we know that neutron is having a neutral, no charge. So now the question arises, if protons are and neutrons are also made up of quark, then how we are telling that, we are saying that minimum charge possible is only electron? We should say that the minimum charge is 2 by 3 electron or 1 by 3 electron. But my dear friends, they are not available in free state. Not available. They are not available in free state. Not available in free state. They are available at certain conditions. Certain condition. So we can't say that they are minimum charge possible. So we consider one electronic charge as the minimum charge, and we called it as a quanta. I have discussed in my previous lecture. Okay. Now let me discuss one question with you. Question is how many electrons are there in 1 coulomb of charge? Can anyone say me how many electrons? How many electrons are possible in 1 coulomb of charge? Can anyone discuss with me? Tell the answer. I know you all know. Please. How many electrons? Anyone? Yes. Good. Very good. Now, yes. Few of them answer. Few of them are answered. Now, how? Q is equal to Ne. We know that. And 1 coulomb. We know that 1 coulomb is equal to how much? 1 coulomb. We know that. Q is given 1 coulomb. Now, N into 1 electronic charge is 1.6 into 10 to the power 19 electron. So N will be equal to 1 by 1.6 into 10 to the power minus 19, and we will get 6.25 into 10 to the power 80, like this. I know you have learned about this in class 10th also. Okay. Now, any problem? We are moving to our next question also. Now, let us solve this numerical. A good numerical mixing of physics and chemistry concept. So, let us discuss this question. A sphere of lead has mass of 10 gram and net charge of this. How many excess electron on the sphere? Anyone? Please try. You all try. I give you 30 seconds. You all try. First of all, all of you try. Try, dear friends. Please try this question. Try, all of you. Try, all of you. Dear student, try, all of you. It is given that we are having a lead sphere, 10 gram, and it has a net charge of minus 2.5 into 10 to the power minus 9 coulomb, like this. How many excess electrons on the sphere? How will you determine that? Are you getting excess electron? That means it must have negative charge. So we can say, see here also, it is given negative charge. So we will equate this with Ne. And what we will get from here? N is equal to 2.5 into 10 to the power minus 9 by electronic charge, that is 1.6 into 10 to the power minus 19. We will get from here some value. This will be the excess electron that we will generate due to this much of charge. Got it? Okay, we will get answer from this. You can solve and get the answer. Now let us move to a second question. B, how many excess electron per atom, per lead atom? You see here, per lead atom, atomic number is given and atomic mass is also given. Let us find. Now we know that how, first of all, let us find the total number of atoms. Total number of atoms. How we will find total number of atoms? It is given that 10 gram of mass, 10 gram by molar mass. We know that it will give 207. We know that when we will take this ratio, it will give number of mole. Now, and we know that in 1 mole we have number of electrons equal to number of atoms equal to Avogadro number, like this 23. We will get some number from here. Let us suppose we get some number. This will show the total number of atoms. Now question is asking that how many excess electron per atom. What we will do? Suppose we get here X and we get here Y. Okay, this much atoms we have having from this much gram of lead. Now number of excess electron, we will, what we will do, we will take ratio of X by Y and we will get some answer, and that will be the answer of our B question. Got it? Any problem, my dear friends? Any problem from your side? Anyone has any problem? And believe me, this question is important for your exam. Any problem? Dear friends, dear students, any problem? Let's play. Okay. I'm explaining once more. No problem. Now, let me raise this. If we have this problem, let me raise this first. Now, let me raise this. What I am doing that you will see once more what I have done. Now, to find the total number of atoms, what I have did, I have taken the ratio of, it is given 10 gram of lead. I have taken 10 gram. You know that one formula in chemistry, number of mole is equal to given mass and by molar mass, like this in chemistry. You know, given mass is 10 and molar mass is 207. We divide here. This will give number of moles, and we know that in one mole there is Avogadro number of atoms or particles, like this. You know, 10 to the power 23. This much of atoms. If this much of moles of lead is available with us, then how much atom is there? Then we will divide, we multiply this with Avogadro number, that is 6.02 into 10 to the power 23. This much atom will be available in 10 gram of lead material which is given to us, and suppose we get some answer, that is Y. This much atom we will get. Now to find how much excess electron, this much excess electron we have got, we are having due to this charge. So, and we are having Y atom. So we will equate like this. If Y atom has X charges, applying unitary method, we are using unitary method. How we will equate? We will equate Y atoms has X charges, then one atom will have how much charges? X by Y. This much. You will see that one atom will have this much excess electron. You can see here You will get from here, my dear friends. Any problem? Any problem? Okay, okay, okay. Good, good, good. Good. Nandini, good. So now let us move further and see our next question. What we are having now? Now let us move for further. Now next properties we are having. This we have solved. Next properties we are having here. We can see here. Next property is that charge is invariant. Charge is invariant. What is meaning of invariant? Invariant means not changing. It never changes. Charge never changes. It is constant. For how? With respect to speed. If we suppose m mass object is moving with v velocity, we have learned earlier also, you must have learned that if mass is moving, then the rest mass of the object changes like this. M is equal to m naught by under root 1 minus v square by c square, like this formula you might have learned earlier also, that mass changes with velocity. Mass changes with velocity. And we also, you have must have learned that when velocity equals to c, then we get m is equal to undefined. You must have learned like this, because with velocity mass changes. But in case of charge, if I throw charge with any of the velocity, then charge value will be invariant, not changing, not variable, always constant. It is invariant. And also will say that if charge is moving, either we are moving it, we are seeing it from inertial frame. You must have learned in your 11th class, inertial frame, or we see it through non-inertial frame. Non-inertial frame. Non-inertial frame. Inertial frame means acceleration is 0, and non-inertial frame means acceleration is not equal to 0. Either we are seeing it from inertial frame or non-inertial frame. We will always observe that total charge is q only. It will never change. That is the property of charge, force property, that is invariant with speed and frame of reference. Frame of reference means observer, which is seeing the charge. Okay, got it? Let us move to our next property. Property of charge. Now, next property. Anyone having any problem, you can discuss with me. Now, let us move to our next properties of charge. It is telling that charge is always associated with mass. What it is meaning that? It is meaning that to have charge, suppose I am telling that an object, suppose one object has plus 2 coulomb, or having 2 electron, 3 electron. That means if it is having electron, it must have gained electron. Or if an object is having 5 plus 5 microcoulomb charge, that is my minus, and here 5. If it is having 5, that means it must have used its 5 electron. So if it is losing or gaining electron, that means it must have any mass, earlier mass. That's why it is gaining or losing. So we will say that charge cannot exist without a mass here, but mass can exist without charge. Mass can exist without charge, no problem. Exist without mass. Mass can exist without charge. We can see here a proton and neutron. Proton has charge of 6.7, like this, 6.7 10 to power, like this, I think 28 kg, I think 28 kg, like this. And it has mass, but its charge is 0. Neutron, its charge is 0. Sorry, proton charge is 1 electron. It is having mass and charge is also present. In neutron, it is having mass, but charge is absent. So we can say that charge is present, but mass is absent. Charge is absent and mass is present. We can see here. So we can say that charge cannot exist without mass, but mass can exist without charge. Okay. This is our fifth property, and believe me, this is the question for assertion and reasoning type. This type of question properties is using assertion reasoning type question, which will ask from this properties only. This type of properties. Okay. Now, next property. Any problem till now? Yes, to any problem till now? Anybody, any problem? Dear friends, please be interactive with me. Okay, good. I think all of you should reply. Nandini always replying. Barika, Afia, and all that should reply. Now, let us discuss our next property. Next property is that charge resides on the surface of conductor. What does it mean? Now, suppose earlier we have learned about the method of charging. I told you that if I give a charge to a body, then it gets either positive or negative, and we have also learned that method of charging like conduction, and also we have learned about induction like that in our previous lecture. Now suppose I have given a body a charge of positive. What will happen if a body gets positive charge? Then charges what will it face? They will repel each other because whole body is getting positive charge. If they are repelling each other, what they will try? They will try that they should go to maximum. They will make a maximum distance between them. Okay, to make a maximum distance between them, what they did? What they goes to surface, because at surface they have a maximum distance between them, and repulsion force gets very less, and it gets stable. So object, to attain its stability, to minimize its repulsion, what does it do? The charges goes to the surface. Okay, now there is one trick. Charges goes to a surface, but there is one trick we can discuss here. Charges go to a surface, but suppose I am having a non-uniform object like this, and if I am giving charges here, what we see that the object has charge density. Suppose we are discussing here charge density. Charge density means charge upon area, and we use a symbol sigma for it. Now let me discuss for an object having a different shape like this. The part of the object which has smaller radius like this, it is defined that the charge density is inversely proportional to the radius. Suppose this portion, it is having a radius r1, and this is having a radius of r2. We can see that r1 is greater than r2. So if r1 is greater than r2, that means the charge density at r1 will be less than charge density at r2, like this. So we will see that here charge density will be less, and here charge density will be more. That's why we say that charges leak. We say that charges leaks at corners, because at corners radius is very less, and if radius is less, then sigma increases. If sigma increases, charges leaks from there. Okay, this type of concept are asked in assertion reasoning type question, so be careful with this concept. Any problem till now, dear students? Any problem till now? Any problem in this property? Now let us move to our next property, that is accelerated charge radiates energy. It is telling that accelerated charge radiates energy. Let me take one example. Suppose I am having charge Q and it is at rest. What will it happen? If it is having if it at rest, what will happen? It will have produce only electric field, no magnetic field, and no radiation of energy. It will never radiate any energy if it is at rest. If the same charge moves, with constant velocity. Suppose constant velocity, I am telling like this, 2 meter per second, and acceleration is 0 here. Velocity is constant, acceleration is 0 here. What will you observe here? We will observe that it will produce electric field, okay, magnetic field, okay, but no radiation. No radiation. It will not produce any radiation. No radiation here. Third case, if the same charges move with velocity not constant, not constant, that means we can say that acceleration is not 0, present some value, maybe 2 meter per second square, 3 meter per second square, like this. Acceleration is having some value. Then we will observe that it produces electric field, magnetic field, and also it will radiate energy. It will also radiate energy. Radiate energy. This also you should remember that if accelerated is present, if acceleration is present, then it will radiate energy. This is the property of charge. It comes through the electrodynamic principle, which you should not important for you in your class 12th. Okay, you should only remember that charge at rest produces electric field only, no magnetic field, and no radiation. A charge having constant velocity, that means acceleration is 0, then it will produce electric field, magnetic field, and no radiation. Third, if charge is having some velocity, variable velocity, acceleration is present, that is accelerated charge, then it will produce electric field, magnetic field, and also radiate energy. Okay, this property you should remember. Okay, any problem till now? Any problem till now? There I will discuss with you important numerical. I will also discuss with you. Good. I will discuss with you. I think tomorrow next lecture I will taking some assertion reasoning question. In that question I will be using these concept only, and I will ask from you all, each one of you. You say this question, you answer this question, and it will be based on the concept of the properties of charges only, which I am discussing today. Okay. Now let us move to our next concept. That is let us move to our next concept, that is Coulomb's law, which we are discussing. Coulomb's law. Let us discuss our next concept, that is Coulomb's law. Now let me discuss what is Coulomb's law. You might have knowing that Coulomb's law, it is also we are having one name also. We also called it as a inverse square law. Inverse square law. Why inverse square law? We will know by seeing its formula. Okay, and I also know that you might have learned this also. Gravitational force, F is equal to G m1 m2 by r square. This is also inverse square law, because in the inverse side we have a square of the distance between the masses, so they are called inverse square law. Okay. Now it is telling that, what does it tell? It tells that if we are having two charges, and both the charges are at rest, that is, one is q1, another is q2, and they are separated by some distance, let a distance be r. It tells that how much force of attraction or repulsion between these two charges. Coulomb stated that the charges will be directly proportional to product of charges and inversely proportional to square of distance between them. Since they the square in the inverse of the formula, that why we say that inverse square law. Okay, and when we remove this proportionality sign, we put here one constant, that is small k q1 q2 by r square, and this small k is constant of proportionality. This is constant, and what does this have value? It is equal to 1 by 4 pi epsilon naught, and value comes, and we know that what is epsilon naught. We know that value, while putting all those value 4, pi and epsilon naught, we get 9 into 10 to the power 9. What will be its unit? I will discuss one by one, all of you, all epsilon naught and all that. Let me first complete about k. Now, what will be the unit of k? Remember, friends, once a question was asked about this dimension and unit of k, and also this epsilon naught dimension and unit, SI unit. I will discuss with you in a previous year NEET question. Now, when we are discussing about k, now from here we can say that k will be equal to f into r square by q1 q2 q1 q2, like this. We will say that in terms of unit, force is Newton, r square that means meter square, q1 q2 that means charge square, coulomb square. What will write here unit? Newton meter square per coulomb square, like this. This will be the unit of k. And if we are talking about dimension of k, now how will you write the dimension of k? For the for f, what will the dimension of f? What will dimension of f? You know, m l t minus 2 dimension of force. R is distance, so we can write here L square. Charges, Q, we will write here current I into T. I have told you earlier in next previous lecture, Q is equal to IT formula. We can write the dimension of Q as current dimension is I, time dimension is T. We can write as IT. So since IT into IT, we can solve all those. What we will get? We will get M L3 T minus 4 and I minus 2. This will be the dimension of k. You check it once. This will dimension of k. Any problem, dear students? Any problem? And believe me, these questions have been asked in your previous year paper, and regarding this epsilon naught and k, that is constant of proportionality in the Coulomb's law. Okay. Any problem till now? Any problem, dear student? Any problem? Good. Please, good, Nandini. I want that all of you should reply. I will be very much happy if you all will interact with me. Good. Now, let us move further. And we are discussing about now. Let move our discussion to this constant. Now, let us see. Now, till now, what we have seen that k is equal to 1 by 4 pi epsilon naught. Now, we are discussing it about what is epsilon naught. We can see that epsilon naught, it is permittivity. What it is? It is permittivity of vacuum. What does it mean? It is a tendency of any medium to allow electric field through it. It is ability to allow electric field. It is measure of ability. It is measure of ability of medium to allow electric field to pass through it. It only shows this. So, what is the value of epsilon naught? We get, since we know the value of k, or we find it experimentally like this. Value of epsilon naught is 8.85 into 10 to the power minus 12. And from here we can write unit and dimension of epsilon naught. Epsilon naught will be 1 by 4 pi k, and we know what was the unit of k. We can reverse here. We have learned in our previous slide. We can see here unit was Newton meter square per c square. We can write here 1 by Newton meter square per coulomb square. We can write here it will be coulomb square per Newton meter square, like this. And also your homework will be to write the dimension of epsilon or epsilon naught. You have to write, and believe this was the previous year NEET question. I think 3 years back it was asked in your NEET exam also. You can write using this formula only. Now let me tell you, this is permittivity of vacuum. If there is no medium, vacuum, or we can say air, like this, no medium. If suppose if there is a medium, now in your exam what will happen, they will change the condition. What they will do, they will change the condition like this. They will say that they are having two charges, they are separated by distance r, and they are moved in, they are put in one medium. Let us suppose medium is, let us suppose they are telling that we are dipping them, we have put them in medium. A medium is any oil. Let us assume any oil, and the oil has permittivity of epsilon, and they will say find the charges, find the forces, Coulomb force. What we'll do, we will say that force is equal to k will get replaced this time. How it will replace? R square. We will write 1 by 4 pi epsilon into q1 q2 by r square. Can you see, my dear friends, what I have did? If there is any medium between the charges, I have replaced this epsilon naught by epsilon. So remember, if there is any medium, if there is any medium, if there is any medium, we will replace what? Epsilon naught by epsilon. We will replace epsilon naught by epsilon, and there is also relation between them, that epsilon is equal to k times, capital K times epsilon naught. This k is different from this k. Never get confused. This is proportionality constant, and this k is dielectric constant. This k is dielectric constant, or we say it as specific inductive capacity. Specific inductive capacity. Specific inductive capacity, or we say it as a relative permittivity. Relative. These all are name of k only. Why we say relative permittivity? Because we can say that we will write k is equal to epsilon by epsilon naught, and since it is having the ratio of the medium permittivity and the vacuum permittivity, so is k is also called relative permittivity, and unit of k will be no unit, unitless and dimensionless. Unitless and dimensionless. So till now, what we have learned, let me take one example, one question, a simple question first. Simple question. First question. Let us suppose if F is force between charges. If distance is doubled, if distance is doubled, and object is object if doubled, and charges are immersed, in medium having k is equal to 40. Find new force. Please try, my dear friends. I am giving 1 minute for you to try this question. Charges, between charges, if distance is doubled, charges are immersed in medium, distance is doubled, charges are immersed in a medium having dielectric constant is equal to 40, then what will be the new force? What will be the new force? Please try. I give you 30 seconds to try the question. Try this question. All of you, please try this question. Now we are coming to a real track of our NEET exam. This type of questions you will see in your exam. Try all of you. Try all of you. Please try. Please try all of you. Okay. Seeing. F by 160. Nandini. Okay. Let me see. All of you, other people also. Try. Other people, Afia, Barika, Monisha. Also, you all try. Now, let me discuss this question. What it is telling that, suppose we are having two charges. Let me assume, since it is not giving that the charges are equal or unequal, so we will assume it as unequal. First of all, Q1 and Q2. We know that if suppose distance between them is r, we know that F is equal to K, small k, Q1, Q2 by r square, and also we can see that we replace this k and write it as 1 by 4 pi epsilon naught Q1, Q2 by r square. This is the first case. Now, second case is this: if the two charges Q1 and Q2, they are immersed in a medium having capital K is equal to 40. Capital K is dielectric constant and it is 40, and also it is giving that distance is double. That means new distance r dash is equal to 2r. So what we will do? F is equal to new force is equal to 1 by 4 pi epsilon naught. What will do? K into epsilon naught. You remember K into epsilon naught. I have written here, see, epsilon naught will be replaced by K epsilon naught. I have replaced this with K epsilon naught into charges will be same Q1, Q2 by distance will be r square, that will be 2r whole square, like this. When we will solve it, what we will get? Q1, Q2 by 4 pi epsilon naught r square and factor of 40 and 4 from this side. What we will get? 160. And we'll see that this is F. You can see here, this is F. So we will say that new force, that is F dash, this will be original force F by 160, and this is your answer. So I think Nandini was absolutely right. Good. I think Nandini was absolutely right. Good. Any problem? Dear friends, anyone has any problem, you can discuss with me. Any problem? Please reply. Any problem in this question? Okay. Good. I think we should all interact with each other, so that session will be more interactive and will be more interesting also. So let us move further and see our next question. Let us see our next question. What we are having? Next question. Let me go further and see what is having the next question. Now, try. This is a question from a previous year NEET paper. I will give you 1 minute time. I think approximately 30 to 40 seconds only, and I believe that you will do. So try all of you. Though objective answers are also given, but I have not given answers here. I think you can try all of you. 30 seconds. Try all of you. All of you try. 30 seconds take time and try all of you. Take 30 second time and try. Take 30-second time and try, all of you. Anyone, try, all of you. Please try. All of you try. Okay. Who has got the answer? Who has got the answer? Who got the answer? Please reply. Who got the answer? Please reply. Who got the answer? Anyone? Try, all of you. Now, no worry. Let me discuss the question. Question is telling that two positive ions each having. We are having two positive ions. Let us suppose we are having two positive ions, each carrying a charge Q. Okay, Q charge, and another is also having Q charge, and they are separated by distance D. F is the force of repulsion. That means we say that F is the force of repulsion this side, and F is the force of repulsion this side. It is telling number of electrons missing from each ions will be how much number of electrons. Okay. Q the charge. It is telling that it is having some. Let us suppose any molecule, any atom, any material, any ions. Let us suppose it has lose n electron. That means charge will be any. If it has a loosed n electron, number of mass, suppose we are saying that n electrons are loosed, or we can say that n electrons are missing. We can say that charges are Q is any here and any here. We have to find n. We have to find n. Now what we will do, we will go to Coulomb's formula. Force is equal to K. What is K? K is 1/4 pi epsilon naught. Okay. Q1, Q2. We can write here NE into NE like this. By distance is D square. From here we will get N is equal to what? N is equal to what? We can write here like this. Force into D square into 4 pi epsilon naught by E square under root. This will be the answer. Okay. Actually, it was the objective question. So this was the one of the option in objective. Okay. Anyone has any problem in this question? Any problem in this question? Anyone? Okay, good. Now, let us move to a further question. I think all of us, rest of us student also, and all that. Nandini is also trying her best. Good. Now, let us move to our next question. Now, this question, I believe that all of you will try here. So try first. This is a good question. Remember, this is a good question. Okay, and it is asked in your previous year paper, NEET, and I believe this will very much helpful for you. So try. I will give you 30 seconds. Try, all of you. All of you should try and participate here. Please try. Try, all of you. All of you, please try. 30-second time. Please try, all of you. We are having 30-second time. I am giving to all of you. Please try. A charge. Let me first explain you the question also. It is telling that I am explaining the question so that you can try. It is telling that a charge Q is placed at the center of the line joining. Okay. It is telling that we are having two charges, capital Q and capital Q, like this. Okay, and a small q charge is placed in between at the center. It is telling that the center of the line joining. Suppose here at the center, here at the center. Okay, answer came. Oh, good, Nandini, good. Some answer came. Okay, good. Let us suppose here we are having a charge small q here given. Now it is telling that the system of the three charges to be in equilibrium. What should be the charge on q? In this type of question, it is asked about two types. First of all, the nature, whether it will be a positive or negative. You have to determine this, positive or negative. Or second, it will be a magnitude in terms of given charge. Okay. So first of all, let us discuss what will be the magnitude. So to be in equilibrium, system to be in equilibrium, forces at this charge, and this charge, or forces on each of the charges should be zero. Net charge forces on each of the charge should be zero. Now, when we are discussing about the nature, we have to find about the nature. How will we determine? Now, let us go to any of the charges. I verify like this. Suppose it is having positive. Here we are not knowing. Let us suppose it is having any of the charge. Let us suppose we take this charge as a reference because we think that we verify here. Let's just suppose if this charge capital Q, what will it do? It will repel this charge by a force of F is equal to small k, charges, product of charges, and let us suppose this distance is r. It will be r square, like this. So, and now we find the forces between these charges. To balance this charge, the other force should be in this direction, and it is only possible if this charge is of negative nature, because it is positive given it should be negative. So first of all, we determine that the charge nature should be negative. So we determine that Q will be negative. Now we will check the option and we will focus on the negative charge only. Now let us find the magnitude. To find the magnitude, here what will the magnitude? We can write here forces will be of F will be K capital Q small q by distance will be, what will distance between them? R by 2. We can say that it will be R by 2 ka whole square. Now to be in equilibrium, this force F dash and this F should be equal. So we will say that to be in equilibrium, F dash should be equal to F. That means K Q by R square by 4 is equal to K Q square by R square, and we know that it will come to be Q is equal to Q by 4 from here. And also we know that answer should be negative, so we'll write minus Q by 4, and I think Nandini was absolutely right. Okay, good Nandini, good. I think all of you should participate. Okay, we will be focusing on a good question. Okay, now let us move further. At the end of the session and the end of the chapter, I will be discussing more good questions with you. This was just for only formula revision. At the end of the session, we will be discussing more good questions also. Okay, now let us move further. Now Let us move further. Now, let me discuss few more concepts. Now, let me discuss one concept of electric field. Electric field. Electric field. What is electric field? Okay. Or we will say, we usually say that electric field intensity. Electric field intensity. We use these two terms to represent electric field. Okay, electric field. We represent it with E, and it is a vector quantity. Okay, what is electric field? Now, first of all, definition, basic definition. We say that suppose we are having charge Q. What happens here? If charge Q is present, what will it do? It will produce some region around it where it will show its effect. Okay, at first, what will it do? It will produce, take some region in space, where it will show its effect, where it will show its effect. Okay. Second, if suppose, now till now we have learned that suppose this is the reason where this charge will show its effect. Now suppose if a small charge is put here, small charge, and that charge is suppose having value 1, and we call it as a unit positive test charge. Unit positive test charge. Because it is having unit value and nature is positive, so we call it as a unit. Because why we take it as a unit? So that it has small electric fields of it, and it will not disturb the electric field of source charge. This is source charge. Okay. Now, what will happen if a small charge comes in the electric field of source charge? It will apply some force. Let us suppose it will apply some force here, F. Then we define electric field at point, we define like this. Electric field at point P, or we say at a point P. If it is a point P, P is equal to force that is applied on the charge by the value of the charge. Since it is a test charge, so we write it as a F by Q. So electric field is defined as force by charge, that is E is equal to F by Q. If we try to calculate, how we will calculate it? We know that force is equal to small k, capital Q. We know between them force, what will be the force between them? This we know. What will be the force between them? We know between them force will be, suppose distance is R and we are having force F, we can write at by Coulomb's law, Q by R square. This is the force divided by Q, 1 by Q. It will get cut, and we will get electric field is equal to K source charge by R square. Electric field at any point we can find by this way. Okay, and it will be radially outward if it is a positive charge, and if it will be radially inward if it is negative charge. We'll discuss here. Don't get confused. We say that if it is having positive charge, then electric will be in this direction. What is this? These are just imaginary lines. Imaginary lines to show the value of electric field. These imaginary lines are called electric field lines. This imaginary lines is called electric field lines. Okay. If the charge is negative, then we draw like this and say that electric field lines is coming inward to a negative charge, and it comes outward from positive charge. Okay. This is the concept of electric field. Now we can say that what will be the unit of electric field? Unit of electric field. we know that electric field is equal to force by Q. We'll say that unit will be Newton per Coulomb. Okay, or one more unit, this will be volt per meter. We will see it later, but you just remember here volt per meter, and this is an important unit. Once upon a time in one of the session of NEET, it is asked question, what volt per meter is a unit of electric field also. We'll discuss it later, but you should know here only. Okay, if we try to find the dimension of E, what will the dimension? We will say dimension of force is, we know that MLT minus 2 force by charge dimension will be IT. We can solve it. What we will get? We will get MLT minus 3 and I minus 1. This is the dimension of electric field. Okay, and also we know that electric field is a vector quantity. It is a vector quantity. Okay, any problem till now, dear students? Any problem till now? Anyone? Any problem till now? Any problem? Please reply, dear students. Any problem till now? Good. Okay. Good. No problem. Good. Now, we are not going to discuss other things, basic concepts which are not our constitution. We are focusing on NEET. We are focusing on the crash course. That's why we will cover the important sections here from here on. Okay. Now, I will take a few examples, questions also, after completing a few topics also. Now, let me move further. Now, we have discussed about electric force. We have discussed about electric field. Now, let me discuss it about electric potential energy. Okay. Before going to there, let me take one simple numerical. Then I will go there. Okay. Now, let me take one example on numerical, because numerical is the most important for exam. Okay. Now, if we are having, I have one example. If we are having a square, in each of the vertex, if we are having one charges like this, okay, charges like this, each is having 2 microcoulomb charge, and the side of the square is 1 centimeter. Find electric field direction on any of the charges. Electric field direction will be where? You have to find this, and also you can find the value also find the value, direction and value also. Let us find both value and direction. Okay, try. I give you 30 seconds to try. You can try any of that. Let take a reference A, B, C, D. Okay, now find electric field on any one of the charges. Fine. We can find the charges also, force also. Okay, you can find electric field, or the question can be also find force on each, any charge. Okay, try all of you. Try once. Try once. This type of question you will see in your exam. You can see this type of question in your exam. Okay, try 30-second time. Try all of you, please try. All of you please try. You are knowing that this is having okay. Answer came. Let me see. Answer came. Okay, so answer came. Okay. I'm not knowing the answer, but okay, good. Let me check. Now, if it is having 2 microcoulomb here, okay, 2 microcoulomb here, 2 here, 2 here. Now, we can take a reference here. Let us suppose here. What will we are knowing that between these two, let me name A, B, C, and D. Okay. Now, between B and C, we know that repulsion, this side, force or electric field. Between A and B, direction of force will be this side. Okay. And also we know that between this D and B, we are knowing that between D and B, these two, we are knowing that between these two, let me change the color of the pen. Yes. Now, between these two, the force will be along this side, like this. Now, my dear friends, one thing you can observe here, the resultant of this force or electric field will be also in its direction. This, if suppose this is force is F, this will be F, and we know that if two forces are perpendicular to each other, and we know that by shortcut also, the resultant will be F root 2, you know, by construct of vector. So net force will be F root 2 plus this force. Let us suppose F dash. This two. Now our job is to find this F and this F dash only. Now how? F is the charge between AD or BC. Now we can write it like this. F is equal to value of K into Q1 Q2. What will the Q1 Q2? Q1 Q2 10 to the power minus 6 microcoulomb, that's why, into Q2, same charge, Q1 Q2 by R square. R is given 1 centimeter. We can write like this. Okay, this is the force. Second, we are talking about F dash. First of all, we write like this. K is this into Q1 Q2. Q1 is 2 microcoulomb and Q2 is also 2 microcoulomb. We can write like this. Q1 Q2 2 into 10 to the power minus 6 into 2 into 10 to the power minus 6 Q1 Q2 by R square. What will be the R? This is given, I think 1 centimeter. You can see it is 1 centimeter. This will be root 2 centimeter. We can write like this. Root 2 centimeter into 10 to the power minus 2 the whole square. You will get F from here, F dash from here, put here and here, you will get the answer, net force, and the direction will be 45 degree from here, or you can take this 135 degree like from here. Accordingly, you can see the option and mark the answer. Similarly, electric field also. Any problem? Now, one question. If suppose we are having 2 microcoulomb on each vertex of a regular hexagon, then what will be the force on the charge at center? First question. Second question. In H2O molecule, you know that this is the structure of H2O molecule. Then, and you also know that what will be the force of attraction between the oxygen atom and hydrogen atom. What will the distance between? What will be the force of attraction or repulsion between this? Force between oxygen and hydrogen atom if bond length is equal to, it is given like this. I'm giving one arbitrary value, don't take it serious. Okay, I'm giving one arbitrary value. Okay, let me give like this, -8, like this meter. Okay, this is a bond length. You have to find the force of attraction or repulsion between the oxygen and hydrogen atom. Okay, 2 questions will be the answer. I will start my next session from these 2 questions. Okay, all of you will try. Please answer. Please mention. You will try, all of you. Say. All of you will try these 2 questions, or I solve it. You will try. Got the question, or I should? Dear students, please reply. You got the question? Good, Monisha. Good. Or other students, you will try. That's the spirit of doctor. Good. Very much impressed by all of you. Very good students. Please reply, rest students. Please reply. You will try this 2 question. Okay. Last 1 minute remaining, dear student. All of you will try now these 2 question. Dear student. Okay, I think there will be some problem maybe from your side. Okay, I will be taking starting my next lecture from these 2 question only. I will ask answer from you, all of you.